Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right. Thank you very much for joining the Industrial Talk Podcast. Once again, my name is Scott McKenzie, and we are broadcasting live from the IMC 2017 conference in beautiful Florida, Bonita Springs, and this is brought about by ReliabilityWeb.com. They put on a fantastic show. Now, this is going to be a great interview, and I'm going to hand the helm over to a gentleman by the name of Buddy Lee, and he's going to interview, and I'm going to say it, whether you like it or not, a legend in the reliability industry. His name is Jack Nicklaus. He is even better looking than the other Jack Nicklaus, and the gentleman that will be interviewing him will be Buddy Lee, and he was on the forum that we had yesterday, talking a little bit about millennials, and he's back to do this interview. And so what I'm going to do is I'm going to hand over, and thank you very much, Mr. Jack, for joining the Industrial Talk Podcast. I look forward to this particular interview and what you have to say.
Thank you very much. Glad to be here. It's an honor.
Jack, thanks so much for doing this today. It's a privilege and an honor to interview you. And would you mind just giving us a bit of an introduction of who you are so that our listeners can know that?
Well, my general occupation at the present time is author and engineer. I make the joke that people buy my books, and there are about 7 or 8 of them currently in print, total of 12 over the past 25 years. And people buy them, and then they hire me to read them to them at outrageous fees.
Very good, very good. Well, for those that may not know it, Jack was had done some service in the United States Navy and was on the Nautilus back a number of years ago as an officer, correct, Jack?
Yeah, I spent first 3 years of my commission career fresh out of the Naval Academy on surface ships. Came up against this brand new nuclear submarine that was in the Mediterranean, and the ship that I was on was a World War II design, and I tried my best as the conning officer under the direction of my commanding officer, an ex-submariner, to put weapons from my ship on that in a theoretical way, in a practice way, on that Nautilus, and I could not do it. It was such a step change in the capability of a warship, and it became obvious I was on the wrong side of the equation. So I applied for and got into the Navy nuclear propulsion program, and within a year of my entrance, the Navy changed the I requirements, which had previously prevented my getting into it, and allowed me to get in, along with some other classmates who became quite prominent in that field. And my first assignment right out of submarine school was the USS Nautilus. At the time, it was the oldest submarine or nuclear submarine in the Navy, and I was a little bit disappointed, but ultimately, service on the Nautilus presented its own unique opportunities, and the camaraderie and the experience with the crew and all the members that were there for a period of my time, 44 months, was a lasting thing. I had more or less weekly contact with one or more of the crew. We have biennial reunions at various parts of the country, and we keep in touch with each other. Fantastic. It's a true buddy system.
That's great.
And that's the best part of the whole service period. I had 2 other submarines under my belt before I was assigned to submarine school to teach tactics to commanding officers and their tactics teams, and prospective executive officer, which was the last job I had in active service. And I went in the Naval Reserve, and at the time, there was a brand new program starting that was designed to monitor the condition of nuclear submarines, of which I had considerable experience at that time. So I became part of the initial team, which ultimately grew to about 160 people conducting monitoring by 1988 on 122 nuclear submarines. In order to change the culture of the Navy, we were trying to change from a shipyard-based maintenance strategy to one that was based on condition monitoring, minimal shipyard involvement, so that we could do the repair work that we needed to do and some of the modification work at the operating sites. It was a real challenge program. We spent a lot of money, but we saved even more. For example, the first 31 ships we took in, the savings were really conservatively estimated and verified by the Government Accounting Office as $1.7 billion, or 11% of the total life cycle cost. And we didn't even get those ships until they were 6 or 7 years into their operating cycle. And the operating cycle was nominally 25 years. And in some cases, when they got to the 25-year point, we were able to extend them safely and reliably through the whole operating cycle of about 35 years, almost 50% increase. That's a real taxpayer benefit.
Yes.
So in the course of that, what we did was develop a whole lot of technologies ourselves. We applied 26 different technologies. 10 of them were ones that we helped develop in one way or another, either assisting commercial suppliers who were putting their equipment into test modes and research and development. We helped them along, put them into the hands of our performance monitoring teams and trained them in the use of the equipment, and basically, in some cases, used DOD, the NASA, and Department of Energy laboratories to develop other technologies, largely in the ultrasonic field, but we were able to then make many of these things commercially available, and they became available to anybody in the world to apply to their assets. So we had a real market impact on the world of what we called predictive maintenance at the time and what we now call asset condition monitoring. I was directly responsible for those projects at one stage of my career in that civil service for 17 years. And then I gradually, through 3 promotions after the initial assignment, became the civilian head of that program. It really was highly successful. It was under deep scrutiny because shipyard workers vote, and we weren't sending ships to the shipyard, and they wanted to know why. So they'd send the auditors in to assess our performance and try to deep six the program. But because of the cost savings and because of going back to the old style of maintenance that the Navy used to practice, was too expensive, we survived, and the program continued right up until the 1990s, by which time we had developed the capability to do most of the analysis on board the ships, and our analysis off ship was not as needed. But the whole process was revolutionary at the time and continues to be so.
Great. I just wanted to, first of all, thank you for doing this, but thank you for your service. I mean, this is a fantastic opportunity to find out about what you did and how you went down through the years and became involved with companies like PDMA and other predictive maintenance technologies. I happened to join CSI about the time I had only been there maybe a year when we delivered all those 2110s to the U.S. submarine fleet and through the David Naval Research. So that's where you and I probably first, around that time frame, became acquainted, and you've been a great mentor to me, and I just want to thank you for that.
Yeah, at one point, when CSI was granted the contract to provide the handheld condition monitoring vibration analysis data loggers, and we bought over 250 of the data loggers to equip our 122 ships plus my teams, as well as the master trend software. And I've talked to Ken Piety and some of the other people who were in charge, like Ron Moore, and they were eternally grateful for that particular opportunity.
Yes, they were. I'm sure. Those continue to be great friends of mine to this day, and I'm very grateful for knowing them. But I'd like to, jump into just a few questions around reliability, if we could. And I know you are a very well-respected thought leader in the reliability industry, so maybe we could just start with the basics, and you could give us a quick idea of your definition of reliability.
Well, it's mine. There are a lot of formal definitions. Lots of people have written about it. But basically what I think reliability is assurance that the asset that you've got is available when you want it and in the condition that you want it to perform its function. That's a simple definition. Reliability is built in at the point of design. And what you have to do for the rest of the life cycle of an asset, whether it's a pump or a generator or whatever, is maintain it to the limit of the built-in reliability that's been designed into it. And that's not easy because failure modes occur that you can't even detect in some ways, and you have to fix them to get the equipment back into operating condition. But reliability means that you keep it up to the point, or maintenance means that you keep it up to the point of its built-in reliability. So that's the way I look at it.
Okay, great. Thank you. You know, one of the things about reliability is that the business case has been proven over and over again in many, many different industries. And yet you've mentioned at this exact conference that the industrial market's been somewhat reserved, reluctant, or whatever about implementing reliability programs. What do you see as the biggest obstacle in implementing or sustaining a reliability program?
Well, the biggest obstacle is a lack of knowledge on the part of C-level executives in organizations. They simply don't understand the concept of reliability. They haven't been trained in it. It's not their fault. They just weren't part of a program that exposed them to it. So they see reliability as somewhat of a maintenance function. And as I pointed out, maintenance function is not to assure reliability other than to maintain the equipment to the limit of its built-in design. So the executives have to be educated. And in order to expend the assets, let's say dollars or manpower or whatever it is, to ensuring reliability, they have to understand what the benefits are, what the return on investment is. So from the people in the mills, at the mill deck, they have to learn how to speak in terms that the C-level executives understand. And generally speaking, that's in terms of dollars and cents. The return on investment in applying, let's say, a high-tech tool to defining degradation that's occurring in an asset so that you can counter it at the least cost at the earliest possible time and at a time you pick rather than the asset picks. Putting people in charge is a very important part of that. And we've now got most of the tools necessary to monitor almost every asset in any kind of operation, whether it's a fast food organization or a steel plant. And it's just a difficult task to get the executives to understand that ideally they buy the equipment ready to be monitored with all the sensors installed and connected up to algorithms and computers that will enable you to get early indication of the onset of failure. What the executives don't understand is that they need to be in a proactive mode, not in a reactive mode. Maintenance personnel should not be fixing things as much as they are detecting early indications of problems and then countering the degradation at a time they choose so that you have minimum downtime, maximum uptime, maximum profitability of the equipment that you have in service for whatever it is that you're selling.
Okay, great. Thank you. So you gave in that answer several things that people can do, but suppose you had just a few minutes to talk with someone and you could only really give one good piece of advice to an organization that's just starting out on their reliability journey. What would that piece of advice be?
Well, it's really two parts. The first part is build a business case for assuring reliability in the assets that you've got at service. The second thing is once you have the business case and you have approval of the executives to proceed to assure reliability, you need a plan. Always have a plan. That one piece of advice has made a big difference in clients that I've served in the past. One of the books that was just published by Reliability Web called Asset Condition Monitoring Management describes, first of all, how to build a business case, and secondly, how to build a plan and what it should contain. And it goes into great detail on that. It's not just applicable to asset condition monitoring, however. It's also applicable to a broader-based reliability program, which has many, many facets beyond asset condition monitoring. It's applicable to any kind of a major function that you have to perform to assure that the assets you've got are well served by the people who are doing the maintenance and assuring the reliability.
Great. Thank you for that very much. I'm really interested in focusing on the senior leadership for just a second. And so if you could talk with the CEO of a large manufacturing organization, what do you suggest would be the best way for him or her to provide leadership to the reliability program?
The best way, in my opinion, is for them to get down with the people who are actually performing these functions of asset condition monitoring. Make the rounds with somebody who's doing vibration analysis so they understand what they're doing. They can look at the various outputs of a vibration monitoring data logger and the analysis software that goes along with it. Get them to understand what an infrared camera can do for them, identifying hot spots or cold spots that indicate the onset of some sort of degradation that has to be countered, that should be countered in an orderly fashion at least cost at the earliest possible time that's convenient to the organization. In response to that, what happens is the asset that's being monitored can be made more available for production. Once it's made available for production, that means that profits can be increased. And it goes directly into the pockets of the C-level executives who get bonuses as a result of high productivity and high profits. So if they understand what people are trying to do that directly affects their pocketbook, in my opinion, they'll pay attention to it and they'll support it.
That's great advice, and I think if a lot of them did understand that we would be in a different situation altogether with reliability. And I want to go now over to some of the things that you've done in the past. You were a founder of PDMA, and you have a lot of experience with electric motors and testing of the electrical circuit system. A lot of field services are being developed within the motor repair facilities. In some cases, they even use PDMA to test their motors. But do you think that reliability engineers should be familiar with the repair and testing procedures followed by their motor repair facility? Do you think the reliability engineers should actually understand the motor repair process?
Not only should they understand it, they ought to control it. The motor repairs are essential to almost any organization that you have, because motors don't last for the life cycle of an organization for the most part. You're either replacing or repairing or refurbishing motors throughout the life cycle of an organization. So you have to dictate specifically what you want from the repair activity that you're employing to repair or refurbish your motors or modify your motors. And you get what you pay for. If you don't have a good specification, and there's lots of guidance on how to build one, there's a good standard or specification for repair, then you're going to get whatever the shop determines is the best for you. And that's not necessary. And usually, if you try to limit the cost, you're going to be getting what you paid for. My attitude towards that is you should be present for at least the final test process of a motor in the shop before it's released to you. But ideally, you're there throughout the repair process for critical motors or very large, high-cost motors to repair. You ought to understand the differential between repair and replacement with a new motor, because once you get beyond about a 60% relative cost of repair versus replacement, you should be seriously considering replacement. And replacement was not just the same identical motor, but motors that are equipped with sensors that enable you to get an even earlier indication of the onset of the problems. I'm in company with a co-author from Canada, Jeff Generalovic, produced 4 books. We've produced 4 books called Motor Electrical Predictive Maintenance and Testing. We look at the theory and then the various tests that can be used to determine whether the theory is being met in practice in motors, to enable you to get a good indication of the onset of failures early on in that process, so that you can schedule repairs when needed, and only the repairs that are needed. In many cases, you don't have to completely rewind a motor to get a good motor. Sometimes a repair far short of a rewind is the ideal solution, because much of the reliability is still there. You just have to reinforce it in some way. But you have to do that with very specific guidelines because everybody has a different set. The motor repair organization may be serving many different clients with different levels of need. You have to specify the need that you have and then ensure that the motor repair shop is doing what you requested. Now, that said, you have to evaluate the motor repair shops for some of the best capabilities. For example, if you're doing re-insulation, you want to use very specific types of epoxy or polyester or copolymer type insulation systems. Some are better than others. Some are better in some applications. You have to understand what's best for you and go to the shops that may not even be in your local neighborhood that can provide the best possible outcome for your motor repair.
Okay, great. Thank you very much for that. So I heard you talk a lot about the technologies that are involved to this point, but I think I'm hearing from you that the people part of this equation is very important. So of those two components, which do you think is truly the more important, or would you just mind talking about the people versus the technologies?
Well, there's no question in my mind that people are the most important factor in the reliability of electric motors and other assets. They have to understand what they're looking at. They have to understand the ramifications, the risks involved in making a bad call or missing a call. They have to be able to explain the need for action to people above them so that that action can be reliably assured. And they, generally speaking, have to see the big picture as well as the small one. They're not just talking about a motor, but they're talking about a whole process, for example, in many organizations. So they need to be able to understand it, control it, and benefit from it.
Okay, very, very good. Thank you. Here's another question for you. If you were the director of reliability at an industrial plant, what key performance indicators would you follow? This sort of brings up the question of reliability data management, which is where I'm going with this thought. And so I want to know kind of what you believe are the key components of a reliability data management program and what key indicators you look at to follow in a program.
Well, the first is consistent long-range ability and capacity to collect data and analyze it so that you can recall it on short notice when you need it, compare things and apply the various analysis methods such as trend analysis, relative comparisons, tests against limits and ranges, correlation analysis where you take information from one technology family or two different technologies to reaffirm the decisions you made concerning the condition of a motor, for example. And that all takes training and experience on the part of the people. So you have to get the people who are responsible for this well-trained and ideally certified, where its certification is available, in the various technologies that are being applied. And then they have to learn how to do the analysis using the methodologies. I mentioned 3. There are about 6 that you can do on site. And if you go to the cloud through the Internet of Things, there are another half dozen key advanced analytical methods that can give you far more information than you can get locally. It's not to say that you should go to the cloud as a first step. You should learn how to do things in-house and understand what you're going to go through when you get to the cloud. And you have to control that aspect of it too, because I recently read an article that said that there's an awful lot of data that's really not being analyzed, but it's being paid for storage in the cloud, and is being abandoned in many cases when whoever was the person who put it there in the first place and had continued to add to it moves on. And
Right.
the new person that comes into that position doesn't understand what's going on, and yet the company's still paying for it. It's a waste.
Yeah.
And it's as much a waste as energy waste when you don't have efficient machinery and you're spending too much on electricity and other utilities necessary to keep your plant operating. If you don't have reliable equipment, you don't have efficient equipment, there's an unseen cost, and that cost is for the utilities that you're continuing to pay for to operate inefficiently. That all deducts from the bottom line. And if you can make that case in terms of dollars and cents to the higher level organization personnel, the executives, you're going to get the assets you need to save those dollars. But then you have to start concentrating on measuring the benefits of what it is you've implemented so that you can continue to show that. I had an interesting example. I had set up for an award-winning program in Cincinnati, Ohio, at the Metropolitan Sewer District of Greater Cincinnati, a program where we had them calculate the cost avoidance for the various fines that they made using the technologies that they had. And in any organization, when leadership changes, people have a different clue as to what, or an idea as to how those calculations will be interpreted. And in this case, the executive in charge discontinued the practice of measuring cost avoidance because she feared that the executives in the political world, which are the owners of this asset, would want those dollars back. And you don't get those dollars back when they're cost avoidance. They're dollars they never asked for in the first place. Right. Had they let the thing go to failure, they would have had to ask for them, and they would have had to cough them up because in the case of wastewater treatment, you have to meet federal standards or you're going to be fined and you have to pay those fines. So there's all kinds of other problems that come about from that. But then when it comes time to cut back on budgets, the first thing that often goes is the thing that has the least exposure, the least return on investment, if you will. And if you aren't calculating a return on investment, then you're jeopardizing the program and the organization. So you have to be very careful about all of that.
Okay, great. Thank you, Jack. That was a great answer. And I know that you recently were involved in redefining and reclassifying some job descriptions for condition monitoring support personnel at a large organization. And that resulted in about a 15% pay increase, I believe including back pay for a couple of years, due to the value they generated for the organization. If you're speaking with a human resources officer, what would you tell them about how human resources can support the implementation of a reliability program?
Well, one of the functions of human resources is to assure retention of personnel who are valuable to the organization. In this case, the personnel who had acquired these skills, who had gone through their training programs, passed all the examinations, been certified in accordance with national and international standards, rightly felt that they should be paid at a little bit higher level than the people with whom they worked on a daily basis, who were mechanics, from which they came in this case. And this organization literally took the people without replacement out of the repair organization and put them into these teams. They were handpicked because of their capability to understand the technologies, to take them past the courses, to go undergo the rigorous years on-site experience with the technologies that they were practicing. And they really truly deserved, because they had gone over and above what ordinary people in the maintenance organization were performing. So they challenged, in this case, the civil service system and asked for increased pay on the basis of what they knew people in the civilian world were being paid. And in this case, the human resources personnel came to me and asked me for the information I had or could get. And over the period of about 6 weeks, I gathered enough information to be able to give them the wherewithal to make the decision on the increased pay. It was a very fair process. The people truly deserved it. I'm glad they got it. And it's indicative in many organizations of the appreciation for the added skills and knowledge that these people bring to bear on a daily basis. They become so much more valuable in almost every aspect of operations and maintenance of plants in this case, and they're serving a truly great cause of ensuring that we have reliable wastewater treatment, which minimizes potential for disease, environmental hazards, and other problems that come from not doing those things.
Okay, great. Thank you. Again, that's great to know about how human resources, it does go back to the people. It always does. I just have a couple more questions. If you came across a plant that had implemented a reliability program and then because of a setback claimed that, well, reliability just doesn't work here, we tried it and it failed, what would be your advice to the CEO, the CFO, the plant manager, basically the leadership and the maintenance department?
Advice is to conduct a root cause analysis to find out why that failure occurred. If, in fact, it was a missed detection on the part of the asset condition monitoring program, learn the lesson and don't repeat it. If it's some other problem, and it usually is, then attack that problem and correct it. Because unless you do a very thorough root cause analysis looking at all the inherent and undetectable problems that occur, let's say, for example, the failure occurred because of poor operating practices or practices that weren't the way it should have been. They weren't following them for some reason. Then you attack that problem. But don't blame the fact that it hadn't been detected, because asset condition monitoring depends upon either continuous or repeated visiting of the data associated with failure. And sometimes you miss it because the failure occurs because of human error that's not predictable, or other factors such as, let's say, a loss of power or power surge that can damage the equipment and cause its rapid decline without the opportunity to detect it with the methods that we've got. If it's a particularly critical piece of equipment and you're only collecting the data on a periodic basis, you may want to reconsider whether you want to go to a continuous monitoring program that would have given you earlier warning of the onset of failure. There's all kinds of reasons why the messenger shouldn't be blamed, or the lack of a message shouldn't be blamed for the problem. Look at the bigger picture. Look at all the factors that are involved, because there are, excuse me, for any particular failure, there are usually multiple causes and contributing factors. And you should be aware of them so you understand where your own vulnerabilities are, as well as the vulnerabilities of the program that you're supporting in asset condition monitoring.
Okay, great. Okay, just one last question then, and that is, how would you begin creating an asset management program for a plant that has never ever had one? How about the plant that's implemented maybe a rudimentary reliability program using condition monitoring? What sort of considerations and ideas would you give them about setting up an asset management plan?
Well, follow the steps that I've outlined in the book, and build yourself a plan. Educate yourself on the benefits that are likely to be obtained from asset condition monitoring. Determine where you are on the spectrum in terms of the capability, which what I've done is outlined a multi-layer approach to predictive maintenance. The simplest one is put very simple tools in the hands of the technicians themselves with only a day or two training on those tools so that they can do some diagnosis, but not necessarily long-term prediction. The second level is to form a team, put multiple technologies in a team. 5 or 6 is good for a start, and get them trained, get them certified, get outside organizations that provide training to mentor these people throughout the first year or so of their effort, and build your program. Once you get it up and running, you may consider continuing to use the contractor as a third tier for occasional replacement of personnel who move on, because if you get the best and brightest people in this type of program, and you usually do, eventually you're going to lose them because they're going to move on. Now, ideally, they're going to be within your organization and they're going to be your champions, but you still have to replace those people, so you have to have a succession plan. All this is built into the master plan that you build for the organization for asset condition monitoring. It's a 5-year plan. It may weigh a pound of paper if you print it out. It'll have 2 things that senior executives look at. First is the executive summary, and the second is the budget. Once they look at the executive summary, they know you've got a plan. Once you've got a plan, they can use that to justify the budget portion, line item that supports your program. So you put in their hands all the ammunition they need to support what you're doing. The plan is the key, and you have to keep that plan current as you develop it, you're going to learn lessons, so you need to change it. The first year, you may change it 4 times, the second year, twice. No less than annually thereafter, so that by the time you get to the 3rd year, you've got a solid program. And by the 3rd year, if it's really a good program, it should be an award-winning program, as has been demonstrated with people who have done this.
Jack, thank you so much for doing this interview today. As always, your mentorship is much appreciated, and this is really sage advice that I believe a lot of folks will actually gain from as they listen to this podcast. I'd like to thank Scott McKenzie of Industrial Talk for allowing me to do this interview here at the Reliability Web 2017 International Maintenance Conference. It's been a real privilege to sit down with Jack and talk to him and have him answer these questions. I hope that you as the audience have enjoyed this and have learned a few things that you can take with you in your reliability journey. Thanks a lot, and everybody have a great day.